All right, here we go. We're going to go ahead and start through the rocket problem. I'm actually going to go use the problem on page 71, problem number 37. I kind of got it set up here already on the paper for you. So we've got an acceleration of 29.4 meters per second squared. It runs for 3.98 seconds. I guess I could add that here. And then it asks, hey, after 3.98 seconds, the fuel loses, or you lose its fuel, so you stop the acceleration and then you go up to the top. There's more to this than we already know because we've got several parts that we can fill in. Example, the final velocity at the top is equal to 0. Our acceleration is 9.81. That's negative here. Also, the acceleration here is negative 9.81 as well. So they really want to know how high it goes and the time it takes to get there. Another question we'll answer is the VF on impact, and we'll go through that. This should be the initial setup you should have already. So one of the easiest things is to start asking questions. Well, my VI, in this case, my VI, starting from rest, down here is 0. So I'm going to do my VF here. Okay, so here we go. This first set, hopefully this shows up. I'm coloring it purple. So I need to find a VF. We turn back to page 58. Page 58 goes, okay, page 58. Can't see, I'm actually turning. We have a couple equations you can use. We have a distance for VF. It's not, we have acceleration time. We have delta x. We have acceleration. I'm just going to use that equation right there because that seems to fit. So VF equals VI plus A delta t. Well, that's really simple. So our VF, we don't know. So VF equals 0. My acceleration is 29.4 times 3.98. And sorry I'm doing this in Sharpie. I really am not a fan, but it makes it easier for you to see. So 29.4 times 3.98. My VF at this location is 117.012 meters per second. Now, that's the first thing that asks us. So that's our VF at the top. So we can say VF 117.012 here. Now, I'm going to fill in my delta y. It doesn't ask for it, but I'm going to fill it in as well. So again, back to page 58. Okay, the easiest equation is actually this one again. So in this case, you have delta x equals VI delta t plus 1/2 A delta t squared. So again, this is 0 plus 1/2 times my acceleration at 29.4 times my time 3.98 squared equals my delta y. I'm going to go ahead and change that. Excuse me. And the only reason I use this equation, barring the one that uses the final velocity, in case I made a mistake here, you can actually correct it and get a little bit better response. So 3.98 squared times 29.4 times 0.5. All right, so this comes out, my delta y is equal to 232.85 meters. 232.9. So that's the first half just while it has fuel. So now let's do the second half in red. We're going to ask the same questions. Well, the same equations now work. So we still want to say VF equals VI plus A delta t. But in this case, we're looking for delta t because we know the VF at the top is 0. Our VI is 117.012 plus, in this case, our acceleration is negative 9.81 delta t. So you move that over, negative 117.012 equals negative 9.81 delta t. Divide by negative 9.81. So negative 117.012 divided by negative 9.81. Our time, our delta t for this half is 11.927. Actually 928 seconds. So delta t for this half is 11.93. I'm not paying attention to significant digits, I'm just running like we've got it. So that gives us our time up here. So let's find our height. We can still use delta y. We have the same equation again. We can say delta y is equal to vi delta t plus 1/2 a delta t squared. So in this case, we delta y. Our vi is 117.012 plus 1/2 negative 9.81 delta t. Oops, I forgot the delta t's there. So my time, 11.93 squared. Whew, that's a big problem. So 11.93 squared times 9.81 times 0.5. That gives me a negative 697.85 there. 11.9 times 117.012. That's a 1395. So minus 697.8. My delta y on this half is another 697.84 meters. Okay, so now we can set that up here. 697.8 meters. That's all we've got. So can we answer delta y? Yes. 697.8 plus the 232.9, which hopefully, if math is still working correctly, it should equal 931. I don't know, let's do it. And then plus 232.9, 930.7. Our time to the top is 11 plus 3, 11.93 plus 3.98 gives a time of 15.91 seconds. Our last but our final impact, we use the same equation. And we're going to do it real quick, down and dirty on this one. Our VF, we don't know. Our VI is 0. Acceleration is negative 9.81. Does this equation work? Because we don't have time. Doesn't work. So, can we use a different equation? Absolutely. In this case, back to page 58. I don't have an acceleration, but I know my height. So VF squared. So I'm just going to run down here. VF squared equals, where'd it go? 2a delta y. So now we have 2 times 9.81 times our delta y of 930. 930 times 9.81 times 2. Square root that answer. Helps if my calculator fingers work. VF equals 135 meters per second upon impact. That is a very long version of problem 37 and a little bit extra just for the funsy. So hopefully that helps. If you have questions, shoot me an email. I don't know where my cursor went.